If you need help balancing chemical equations, this is the video for you. Alright, let's get started. Chemical equations show the reactants and products of a chemical reaction. So the reactants are the substances that go into the reaction, like here for example, and the products are what result from the reaction, like that. So to understand chemical equations, you need to know a few symbols and what they mean. Plus signs are used to separate different substances. So it'll separate two reactants from each other. Like A is a different substance than B, but they're reacting, so they're on the same side of the equation. A plus sign can also be on the product side of an equation if there are multiple products. The next symbol you need to know is an arrow. An arrow is used to separate the products and reactants, and you read it as yield. Another type of arrow could be something that looks like this, which indicates a reversible reaction. So the reactants go to products, but the products, these substances, can also become the reactants again. Another important thing to know is that in most equations, they will indicate the state of matter in parentheses after each substance. So here, this shows what letters mean. Now, we're going to walk through a sample problem to understand different steps to get the answers and how to balance an equation. Let's get started. So for this sample problem, we are given the word equation. A word equation gives the names of the substances involved and the names of the reactants. And you can use the word equation to write out the skeleton equation, or also known as the formula equation. The formula equation or skeleton equation uses the chemical formulas of the substances in equation form. It'll look something like what we saw earlier. Alright, so here we have oxygen gas and hydrogen gas combined to form liquid water. So we're going to try out writing a skeleton equation. First, we have oxygen gas. Oxygen gas, O is for oxygen, and we know that oxygen is one of the Hunkelbrief elements. If you don't know what that means, ask Mr. Seguin. He has it on his lab coat. And so oxygen in its elemental form is going to have a subscript 2. And then we're going to indicate the state of matter by putting G in parentheses for gas. And then we have our next reactant, which is hydrogen gas. Hydrogen is also a Hunkelbrief element, so it's also going to be H2, and it's a gas. Next, we have an arrow, which means yield. Okay, so oxygen gas plus hydrogen gas yields water. We know that the chemical formula for water is H2O. And so, that's our skeleton equation. H2O is a liquid also. Pretend that there's extra space on this whiteboard. There we go. Water is a liquid. So there's our skeleton equation. Next, we're going to balance the equation. Notice there are 2 oxygens and 2 hydrogens on the reactant side of the equation, while there are 2 hydrogens but only 1 oxygen on the product side. And according to the law of conservation of mass, matter is neither created nor destroyed in a chemical reaction. So the mass of the reactants has to equal the mass of the products. In our skeleton equation here, there's not the same number of oxygens on either side of the equation. In order to fix this problem, we use coefficients to write in front of the substances to get the same number of atoms of each element on either side of the equation. So I'm going to start writing the balanced equation by writing down the skeleton equation. So I'm just going to copy it down here. So a really good trick to use when you're starting off learning balanced equations is to write underneath the equation, just write some little notes for yourself. So let's see. Oxygen. How many oxygens do we have? On this side of the equation, we have 2. So just put a little 2. These are just notes for ourselves. There's 2 hydrogens, so we're going to indicate 2 hydrogens. We'll just put our arrow here to remember that we're moving to the product side. And then we're going to say how many oxygens? There's 1 oxygen. And how many hydrogens? There are 2 hydrogens. So we can already see, this is a great way to see that we need to do something to fix this problem of the missing oxygens. So we use coefficients in front of it. So let's see what we can do. We want to make this oxygen 2. So if we put a 2 in front of the water, then we have 4 hydrogens and 2 oxygens. I'm gonna go over to the other side of the equation. Now we're good on oxygen, but now over here we have 2 hydrogens, over here we have 4. So we're gonna make this 4 by putting a 2 out front. And then you see we have 1, 2, 3, 4 hydrogens. All right, so that's how you balance an equation. So now I've written out some practice problems, just the skeleton equation, that we're gonna practice balancing. So I'll just run through the process, and you can pause the video if you want to practice it yourself. I'll show the equation more clearly. Or you can just watch me try to solve this problem and see what happens. All right, so here we go. First, we're gonna start off with counting how many of atoms of each element are in the equation. So for the products, there is 1 sodium, there's 1 OH, and so since the OH stays stays together on both sides of the equation, and the oxygens and hydrogens don't separate, we don't have to count the oxygens and hydrogens separately, we can just do it together. So here we have 1 calcium and 2 bromines. On the other side of the equation, we have 1 calcium, 2 OHs, 1 sodium, and 1 bromine. All right. One more thing I want to add. So something that's important to remember is that subscripts, we never change those when we're balancing equations. If it has a 2 here, it's going to stay a 2 here in our balanced equation. We can only modify the amount of atoms of each element by adding coefficients at the beginning of the substance's chemical formulas. First off, let's balance the bromine. We have 2 over here, 1 over here, so we're going to add a coefficient of 2 to this. And then we have 2 bromine, and we want to make sure we keep track of this, 2 sodium. So now our sodium is uneven. Now we have 2 sodium over here, but only 1 here. So let's add 2 as a coefficient. So now we have 2 sodiums. And that changes the number of hydroxides we have. Luckily, that's good for us because hydroxide was another substance that was not balanced. So now we have 2 hydroxides, and good, we have 2 hydroxides here already. Now let's just check. This stays the same, this stays the same, and this stays the same because we didn't add any coefficients. So now let's make sure we have 2, 2, 1, 2, 2, 2, 1, 2. And then the reason that I wrote the elements in this order, in the same order on both sides, even though they aren't the same up here, is because you can just check the numbers and you can go quick. You can go 2, 2, 1, 2, 2, 2, 1, 2. So that's an equation that is now fully balanced. It looks very nice. Now let's try the next one. All right, here we go. Now we have an equation that's a little bit more difficult than the last ones. If you're gonna follow along, you can write down the equation. Feel free to pause the video anytime you want. Here we go, that's better. I have the elements involved in the reaction written down. So now, let's write down how many we have of each. We have, now, this is what we have so far. Let's start with this chlorine. We have 2 chlorine over here, 1 over here. So we're gonna add a coefficient of 2, which means now we have 2 chlorine and 2 sodium. Now over here, that's good, we still have 2 chlorine. And now we want to have 2 sodium, so let's add a 2. Now we have 2 sodiums, and that changes the number of hydrogens. Now we have 2 hydrogens, 2 carbons, and 6 oxygens. Now, let's see if anything else is different. I think it's all balanced now. Let me just double check. We have 1 of that still, we have still 1 of that. We didn't change these, so 2, 2, 6. Now look at that. We thought that was gonna be hard, but we only had to have 2 coefficients. Let's just see, 1, 2, 2, 2, 2, 6, 1, 2, 2, 2, 2, 6. There you go.